So if we fill in the table of values for y equals 2 to the x, and then start graphing these points, we have negative 3 1/8, negative 2 1/4, negative 1 1/2, 0 1, 1 comma 2, 2 comma 4, 3 comma 8. And the general shape of all exponential functions will look like this. One of the things that we'll add to our exponential functions is that there is an asymptote at y equals 0. The reason for that is if you think, and horizontal asymptotes tell us what's happening to a function as x either gets very large positive values or as x gets very large negative values. In this case, the asymptote is here because of x getting to very large negative values. Can you see if I keep plugging in larger and larger negative values for x? If I plugged in negative 10, that technically would be 1 over 2 to the power of 10, which would be a very small number. But it wouldn't equal 0. I can get smaller and smaller and smaller, but I'll never equal 0 because the only way a fraction is equal to 0 is if the numerator is equal to 0. And with a negative exponent, your numerator will always be 1 over something. And so on the graph, it gets really, really close to y equals 0, but never equals it. And so we show that on a graph by drawing an asymptote.
So unless your graph was translated with the asymptote, the answer can also be 0?
Right, unless the graph, and we will do that. If you take this and went minus 3 at the end, it would get translated down 3, and your asymptote would move to y equals negative 3. But what we have here is what we're going to call a parent function. This is one of the parent functions for exponentials. How many parent functions are there? A ton, because you could have a 3 to the x graph, a 5 to the x graph, an 8 to the x graph. They all look similar, but the numbers change a little bit. So some patterns that we're going to notice. This is the y, whoa. This is, whoa. There we go. This is the y equals 2 to the x graph. And I'm going to label, even though we have a lot of points on here, I'm going to label 2 points in particular. I'm going to label 0, 1, and I'm going to label 1, 2. And right underneath this, let's graph 3 to the x. And with the 2 points that we've labeled, I want you to tell me how they are going to compare from one to the other. Yes?
So this is hypothetical, right? You said they all look similar.
Yes?
Say someone, totally not me, didn't know what they were doing. Could they kind of just like write an asymptote with 0 and kind of draw a line going upwards and get
Somewhat, yeah.
Nice. I mean, not for me.
Because part of the mark on any exponential graph is, do you have the correct shape? So the shape of an exponential has that asymptote, and it has the swooping up. But if you look at y equals 3 to the x, what's going to happen when you plug in 0 for x? You're going to get 1. Can you see that maybe for every exponential graph, you'll have 0, 1? Okay? What happens when you plug in 1 for x? You get 3. So with 2 to the x, you had 1, 2. With 3 to the x, you have 1, 3. What point do you think you'll have with 4 to the x? 1, 4. And 5 to the x will have 1, 5. I mean, you could think about a table of values. I could label another one. The next one up here would be 2, 9. It's going to have the asymptote at y equals 0 as well. And we have our parent function graph for y equals 3 to the x. What's going to happen when you have a half? Would you agree that when you plug in 0, you're still going to get 1? What's going to happen now when you plug in 1? You're going to get 1/2. Now, technically, this is enough to graph this completely. Right? I have 0, 1 and 1, 1/2. And instead of a function swooping up, we're going to find out that this one swoops down. We could fill in the rest of our table of values. Here we're going to get 1/4, 1/8. Can you see that if you put in a -1, you would get 2 and 4 and 8? That point's just a little bit off, and that one, oh well. Okay? But the key points on this one are 1, 1/2, and still 0, 1. And we still have an asymptote at y equals 0. So in section 5.2, they summarize this. An exponential function is any function that can be written in this form, y equals a to the x, where a is a positive number. And they talk about some of them swooping up, and you can draw in your asymptote here at y equals 0, and some of them swooping down. You can draw the asymptote with y equals 0 in there. However, sometimes it's easier to actually think of numbers to see this. So I redrew our 3 to the x graph, and I picked another fraction, like a 1/5. This is in section 5.2. So if you want to add those graphs to see extra graphs on there as well. But it's just the basic shape of all of our exponential graphs are either swooping up or swooping down. And it all depends on where that second point is that you label. Like for a 3 to the x, you label 1, 3 along with 0, 1. It has to swoop up. And with x there, being, 1/5 being the base, you'd have 1, 1/5. It would have to swoop down.